Good day, everyone. Hi, I'm Ms. Charu, one of the chemistry lecturer from Center for Pre-University Studies, MAHSA University. Today, I'm going to share with our SPM candidates on how to answer SPM Chemistry Paper 2. So, I'm going to share my screen with you guys. All right, so this is a part 2 video. That's a lot of topics in Form 4 and Form 5. And today I'm going to focus on Chapter 4, Thermochemistry. Let's look at the question, and all the questions are from SPM past year questions. So we will start off with SPM 2016 question. Let's look into the question one by one and solve it together. So let's read the question first. Compound X is known as a clean fuel. The combustion of compound X produces blue flame without soot. Okay, write a chemical equation for combustion of compound X. Okay, so let's look into what is the compound X. So this compound X, it has 1 carbon, 2 carbon, and 3 carbons. So it is C3. And how many H that we have? 1, 2, 3, 4, 5, 6, 7. So there's H7 and there's OH. So this is the compound X. So how are we going to write the combustion equation? But before we write the combustion equation, we have to take note here. They have given the clue of blue flame without soot. What does it mean? It means it is a complete combustion. All right. So combustion, we have 2 types, which is complete and incomplete. So let's look what is complete and incomplete. Complete meaning it has burned. Okay, let's say compound X. Okay, compound X burned in excess oxygen. Okay, so that is complete combustion. If it is incomplete, it is going to be compound X burned in limited oxygen. Okay, so the difference here between complete and incomplete is the observation part wise is this is blue flame and no soot. Okay, so this one will be yellow flame with soot. Okay, so now let's look into how to write the equation. C3H7OH plus we will have oxygen. Write it first. Write the reactants and write the products first. So you have carbon dioxide plus water. Okay, so now there's 3 carbons. So we are going to make it balance on the right hand side. So we are going to add a 3 here. So your left hand side and your right hand side, they are balanced for carbon. Let's look into how many H atoms that we have. We have 7 plus 1 here, so it's 8. So we are going to make balance on the right hand side by adding a 4 in front here. All right, so now we're going to look and balance for oxygen atom. So there's 6, 3 times 2, okay, 6, and that's 4. So in total, you have 10 O's over the right. So we have to make sure that there's 10 O's over the left. So there's already 1 O here. So we're going to add 9 over 2. Because we can cancel this 2 and 2, and you will get 10 over here. 9 plus 1. Okay, but we don't want the denominator to be there. So what we are doing is, we are going to times it, okay, to all these reactants and product. So end of the day, you will get 2C3H7OH. Okay, you will get 9O2 and 6 carbon dioxide and 8 H2O. All right. So when you have 2C3H7OH plus 9O2, you will get 6 carbon dioxide and 8 water. This is the complete reaction equation and this is the answer. The question just now, it was 1 mark. So you will get directly 1 mark. There's no any half marks for it. If you give a complete correct equation, you will get 1 mark. All right, so let's look into SPM 2017's question. All right, so let's read the question. Table 2 shows the value of heat of neutralization for the reaction between two different acids with the sodium hydroxide solution. So the first one is HX, we don't know what is the X, and the second one is ethanoic acid. So ethanoic acid is weak acid. Okay, and they have given you the heat of neutralizations. Okay, let's look into the question on what they want. What is the meaning of heat of neutralization? So what does heat of neutralization means? Heat produced when 1 mole of water formed or produced from the reaction between acid and alkali. Okay, so this is heat of neutralization. You have to remember the definitions of it. All right, so moving on to the second question. Based on table 2, suggest acid HX. Let's look into table 2 first. Okay, table 2, it shows that it's negative 57.3 and it's reacting with a strong alkali. So usually if it's negative 57.3, it's going to be strong acid with strong base or strong alkali. So if it's strong acid, okay, strong acid, we are going to know that this HX is hydrochloric acid. Sorry. Okay, it's hydrochloric acid HCl. Okay, so that is the HX. All right. Moving on to the third question, they ask why there are differences in the value of heat of neutralization. Why there's a difference between the strong acid with strong alkali and with weak acid and strong alkali. Why there's a difference? Because you have to understand first is strong acid. What is strong acid? What is the difference between strong acid and weak acid? Strong acid dissociates completely in water. Okay, and weak acid dissociates partially in water. Okay, so this is partially, this is completely. So what it does is weak acid dissociates partially in water and some heat released during the neutralization. Okay, the neutralization is used to dissociate, the acid completely in water. Hence, the heat given out will be less. Okay, so the moment when you talk about completely and partially, you will get 1 mark here, 1 mark here, And this part, when you explain that some heat is released during the neutralization, is used to dissociate the acid completely, you will get 1 mark here, a total of 3 marks. This is why there's a difference in the value of heat of neutralization. All right, so let's look into SPM 2018's question. All right, so let's read the questions first. The heat of combustion of propanol is negative 2030, which is 2030 kilojoule per mole. This is sometimes also written as kJ mole per negative 1. This is also known as kilojoule per mole. All right. The number of carbon atoms of propanol is 3. So that's 3 carbon atoms for propanol. If 1.08 gram of propanol is used to heat 200 centimeter cubic of water, calculate the number of moles of propanol. So we are going to look into how to calculate the number of moles of propanol. So what is the thing that you have to take into account when you want to calculate the number of moles? How you can get the number of moles? Let's look into that one by one. Okay, and they ask us to calculate the temperature change also. So let's solve the first one. Okay, so the first one, number of moles is equals to mass over molar mass. Okay, so mass will be in gram, molar mass will be gram per mole. Okay, so here the mass given is 1.08 gram. Okay, so it's 1.08 gram divided by, let's look into the molar mass. They have given you the molar mass, which is 60 gram per mole. So you just write 60 gram per mole. So you can cancel this. Okay, so you will get 0.018 mole. So this is the answer. Since it's 2 marks, you are going to get 1 mark over here and 1 mark for your answer. So you have to be very clear. In order for you to calculate the number of moles, the formula is mass over molar mass. Make sure the mass in gram, and you can cancel this. So when you bring up the mole negative 1 to the top, it will become mole. All right. So we have calculated the number of moles of propanol. Let's look into the second one. Calculate the temperature change during the reaction. So how are we going to calculate the temperature change? So temperature change is, they want us to calculate what is theta. Okay. So before that, we have to know heat. Okay. Heat released or absorbed is going to be mc theta, the formula. Okay, so now let's look here what they have given. They have given heat of combustion. How they get the heat of combustion? Heat of combustion you can get from heat released or absorbed. This is combustion, so combustion means it's released. Okay, so heat released divided by the mole. Okay, that is why you will get kilojoule per mole. All right, so now how are we going to get the heat release? Because in order for us to get the theta, we need to know what is the heat released. We are going to find the heat released from the heat of combustion. So heat released is equals to heat of combustion. Just now it was 2030. We are not going to take the negative. This negative, it shows it's exothermic reaction. Okay, if it is positive value, it is endothermic reaction. Okay, so this reaction for combustion is exothermic reaction. All right, so we are not going to take the negative for the calculation. We are going to take only the value. So let's look 2030 It is in kilojoule. Okay, but remember, when we calculate here for the heat release, we will get it in joule first. So we are going to convert the kilojoule to joule. So we are going to times by 1000. Okay, and we are going to times the mole, because heat release is equals to heat of combustion times the mole. So the mole here that we have calculated previously is 0.018 mole. So we are going to times it with 0.018 mole. So we will get the answer 36,540 joule. It will be in joule. All right, you have to make sure that you get it in joule. I will tell you why in a while. Okay, so after you get this, you know this is 36,540 joule is equals to mass. Let's look into the question. Where's the mass? They have given, yes, the mass of water, which is 200 centimeter cubic. Okay, so 200 centimeter cubic is equivalent to 200 gram. Okay, the inner part of it, how we get this 200 gram is from density. Okay, so you know that density is mass over volume. Okay, you know that density is mass over volume. So mass over volume, we don't know the mass. We are going to calculate the mass. So if we are going to bring down here. So we are going to calculate the mass over volume. So we're going to calculate the mass. Mass is equals to density times volume. Remember here in the question, they have given you the density of the water, which is 1.0 gram per centimeter cubic. So it's going to be 1.0 gram centimeter negative 3 times the volume that they have given here is 200 centimeter cubic. So we are going to times, with 200 centimeter cubic. This one and this one will cancel. So you will get 200 gram. So this is how you get 200 gram. Okay, so your mass is 200 times with the C, which is the specific heat capacity that has been given in the question, which is 4.2 joule per gram per degree Celsius. So, okay, so here you will have gram times 4.2 joule gram negative 1 degree Celsius negative 1. All right, this theta you don't know. Okay, so you will cancel this and this. Okay, so you will have your theta to be 43.5 degrees Celsius. So you bring this over here, divide. So that means 36,540 divide by 200 divide by 4.2, sorry. You will get 43.5 degrees Celsius. So since the question wants you to find the temperature change, this is the temperature change. So here you will get 1 mark when you get the correct heat released. So after you get the correct heat released, you will get 1 mark here when you get a correct theta. All right. So that is how you get 2 marks for this question. All right. So we have done looking into the first question. Let's look into the second question. Second question is, write a chemical equation for the complete combustion of butanol. So you have to know what and how butanol will look like. So butanol is 4 carbons. So we are going to draw it. It's going to be 1, 2, 3, 4, and you will have H atom for this 1 carbon, that's 3. For this carbon, it's going to be 2. For the carbon here, it's going to be 2 H atom. For this carbon, you will have H, OH, and H. So your formula for this is going to be C for 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be H9OH. This is the molecular formula for butanol. Alright, so now since they want us to write the complete combustion equation, we know complete means in excess oxygen. Alright, so we're going to write C for H9OH plus O2, you will get carbon dioxide and water. Right? So now we're going to balance the equation. So how? We have 4 carbons on the left hand side. So we are going to make sure that there's 4 carbons on the right hand side as well. So we're going to add the 4 there. Okay, so and then we have 9 plus 1, 10 H atoms. So we have to make sure that there's 10 H atoms on the right hand side as well. So 5 times 2, that's 10 H. Alright, so now we're going to balance the O. So in order for us to balance the O, we have to look into the right hand side first. Okay, so right hand side there's 8 and there's 5. So in total you have 13 O's atoms. Okay, so we have to make sure that there's 13 O atoms over here as well. So there's already 1 here. So you need 6, 12 here. So 12 plus 1, so it's 13. So this is the balanced one. C for H9OH plus 6O2, you will get 4 carbon dioxide and 5 water. Okay, so this is the chemical equation of complete combustion of butanol. You will get 1 mark if you provide us the correct equation. Alright, moving on to question 3. Alright, so let's look into the diagram here. Diagram 8 shows the apparatus set up and the temperatures recorded to determine the heat of neutralization using 2 types of acid, acid X and acid Y. Okay, we don't know what are the acids with sodium hydroxide solution. This is strong, strong alkali or base. Okay, so let's look into the diagram. Okay, and let's look into the question first. Based on the diagram 8, calculate the heat of neutralization for set 1 and set 2. Then you have to suggest the types of acid X and acid Y. They provide you specific heat capacity, which is 4.2 joule per gram per degree Celsius, and they have provided you the density of the water. Alright, so then let's look into how and what we have to do first. Since they want heat of neutralization, we need to know the number of moles and we need to know the heat released. Then only we can calculate the heat of neutralization. So heat released divided by the number of moles. Heat released or heat absorbed. Okay, number of moles. Okay, so we have to calculate this and we have to calculate this. Then only we can calculate heat of neutralization. So let's do for set 1. So set 1. Okay, so number of moles we are going to calculate. Since in this diagram there's acid and there's base, we are going to calculate for both. Okay, so let's calculate for acids first. Okay, so acid X. Okay, set 1 focuses on acid X. So we're going to calculate the number of moles of acid X. So how are you going to calculate the number of moles of acid X? The formula is mV over 1000. This is concentration, okay, molarity. And this is volume. This volume, why we are dividing by 1000 is because the volume that they have given is in centimeter cubic. Let's look here. It's in centimeter cubic. Since it's in centimeter cubic, we have to divide by 1000 in order to change it to dm cubic. Okay. So, MV equals to 1000. So let's look into the molarity of it. What is the molarity? It's 2.0 mole per dm cubic. So 2.0 times, what is the volume? The volume here is 50. Okay, 50 centimeter cubic. So the volume is 50. Divide by 1000. Okay, you will get 0.1 moles of acid X. Alright, so now we are going to calculate the number of moles of NaOH, sodium hydroxide. The same formula, MV over 1000. Okay, let's look into the molarity here. The molarity is 2.0 mole per dm cubic and the volume is 50 centimeter cubic. Is the same as the acid X. So it's going to be 2.0 times 50 divided by 1000. You will get 0.1 moles of NaOH. Okay, done calculating the number of moles of acid and number of moles of sodium hydroxide. You are going to do for heat released. So heat released is equals to mc theta. So where we are going to get the mass from? Okay, you know that density is equals to mass over volume. In order for you to get the mass, is going to be density times volume. So density times volume, let's look into what is the density. They have given the density is 1.0 gram per centimeter cubic. So 1.0 gram centimeter negative 3 times the volume of it. Okay, the volume of it is 50 plus 50 because it's a mixture. Okay, so how we are going to take this and you mix it with this, you will get this. So 50 plus 50, you will get 100. Okay, so it's going to be 50 plus 50. So you will get a mass of 100. All right, so you can substitute here. And the specific heat capacity given is 4.2 joule per gram per degree Celsius. So 4.2 joule per gram per degree Celsius. Okay, and the theta difference here is, you can see final is 42.5 degrees Celsius and the initial is 29 degrees Celsius. Okay, so you're going to take the final minus the initial. So the final just now was 42.5 degrees Celsius minus 29.0 degrees Celsius. You will get a heat release of 5670 joule. Because this gram and this, it will cancel off. This degree Celsius and this degree Celsius will cancel off. You will left out with a joule. All right. So after you calculate the heat release, we are going to calculate the heat of neutralization. Okay. So the heat of neutralization is heat released or absorbed. Okay. Divide by the moles. So here 5670 joule divide by what is the moles here that we have calculated is 0.1. So it's going to be 0.1 mole. So you will get 56,700 joule per mole. But there's a negative because this is heat released. Okay, so this is heat released. Okay, the neutralization, it's heat released, so it's going to be a negative. So it's also equivalent to a negative 56.7 kilojoule per mole. Okay, so this is the heat of neutralization for set 1. All right. So where do you get marks and how many marks is it? Let's look into here. You will get 1 mark when you calculate the number of moles of acid X, and you will get 1 mark when you calculate the number of moles of sodium hydroxide. So it's a total of 2. And you will get 1 mark here when you calculate heat release for set 1. And you will get 1 mark here when you calculate heat of neutralization for set 1. So a total of 4 for this. Okay, the total marks for this question entire for 1 and 2 is 10 marks. So they allocated 2 marks for the second question and 8 marks for the first question. So let's look into another 4 marks. What we have to do? We have calculated for set A. Now we're going to look into set 2. Okay, just now we calculated for set 1, now set 2. All right, so set 2 is the same, but now we don't have to calculate the number of moles. Okay, we are going to calculate straight number of moles for acid Y and sodium hydroxide is more or less going to be the same because the volume and concentration is the same. So you know for acid Y is 0.1 moles. For NaOH is going to be 0.1 moles as well. So number of moles. Okay, so now we are going to calculate the heat released, which is mc theta. So mass is the same where we have 50 centimeter cubic plus 50 centimeter cubic, you will get 100 centimeter cubic of the mixture. So we are going to take the mass from here. All right. So you know density is equals to mass over volume. Mass is equals to density times volume. So mass is equals to density is 1.0 gram centimeter negative 3 times with 100 centimeter cubic. Cancel this, you will get 100 gram. So the mass is 100 gram. The specific heat capacity is going to be 4.2 joule per gram per degree Celsius, and you times with the theta. Theta is the temperature change. So let's look at here from 41.0 degrees Celsius. Okay, from 29.0 degrees Celsius, it becomes 41. So 41 is the final temperature, and this is the initial temperature. Okay, this is T final. So we will take T final minus the T initial. So you will get 41 degrees Celsius minus 29.0 degrees Celsius. So you will get the heat release of 5040 joule. Because this is gram, cancel this one, cancel with this one too. Okay, so you're left out with a joule. So after you find the heat release, you are going to calculate the heat of neutralization, because that is what we want here, right? Heat of neutralization. The heat of neutralization for set 2 is 5040 joule divided by the number of moles, so which is 0.1 moles. Okay, so you will get a negative here, indicate its exothermic reaction. So negative 0.50400 joule per mole, or you can even give it as 50.4 kilojoule, a negative 50.4 kilojoule per mole has the heat of neutralization. So you will get 1 mark here, you will get another 1 more mark here. So a total of 2 marks for this calculation for set 2. Okay, so let's look into another part of it in which after you calculate the heat of neutralization for set 1 and set 2, you have to suggest the type of acid X and the type of acid Y. What could it be? Let's look into the heat of neutralization. For acid X, okay, for acid X, the heat of neutralization is negative 57 56.7 kilojoule per mole. So let's write here, for acid X is equals to negative 56.7 kilojoule per mole, and for acid Y is going to be negative 50.4 kilojoule per mole. Alright, so now we are going to indicate what is acid X and what is the type of acid Y and what is the example it could be. So usually when you see if it's more or less negative 57, negative 56, it's going to be a strong acid. Okay, and this is going to be our weak acid. So what could be the example of strong acid and what could be the one example of weak acid? So let's give acid X. Okay, acid X here, since it's strong acid, we can give it as HCl or hydrochloric acid. Okay, and acid Y is weak acid. So weak acid, we can give an example of ethanoic acid. Okay, CH3COOH. This is weak acid and this is HCl, a strong acid. So you will get 1 mark over here and another 1 more mark over here. Okay, so 2 marks plus another 2 marks here, 4 plus 4 here. So a total of 8 marks for the question 1. Okay, so let's look into question 2. Explain why there's a difference in the temperature change between set 1 and set 2. So let's explain why. In set 1, okay, in set 1, acid X. Okay, so acid X is strong acid. So what does strong acid do? Strong acid dissociates completely in water, and has for set 2, acid Y, yeah, weak acid. So weak acid dissociates partially in water. Okay, so some of heat released during neutralization, okay, is used to dissociate the acid completely. Hence, the heat released will be less. That is why there's a difference. Okay, so it's a strong acid and it's a weak acid. There's a difference there. Why? Okay, so you will get 1 mark here that you indicated a strong acid and a weak acid, and a 1 mark here to give why, because some of the heat released during the neutralization is used to dissociate the acid completely in water. So that is why the heat released will be less. Okay, so that's 2 marks for the second question. Okay, so 2 plus 8, you will get 10 marks of it. So I have discussed SPM 2016's question, SPM 2017's question, and SPM 2018's question on how to calculate the heat of neutralization and how to write the equation of combustions and everything. Alright, so this is what you have to really know, the formula MC theta, and how you get the formula for the neutralization, which is heat released or absorbed divided by the moles. That is why you get kilojoule per mole or joule per mole. Alright, so this is what you have to know for chapter 4 thermochemistry, and also the definitions of the heats. Okay, we have heat of combustion, heat of neutralization. We have different heats, so you have to know what does it gives, the definitions of it. All right, so according to the definition you can create the equation. All right, so I have discussed all that, so thank you, and let's look into, give me a moment. Okay, so now thank you for lending me your ears. Don't forget to fill in the Google form at the comment section. All right, it will be in the comment section. Kindly fill up the form for me. If there's any improvement that I have to do, I will do it. All right, I will definitely improve. And if you are interested in our foundation program, we will definitely happy to hear from you. And we have two types of program, which is foundation in science and foundation in business. All right, so you can get know more details about our foundation program in our website, MAHSA University website, so you can get to know about the entry requirements and everything. All right, I can't wait to meet you guys next year, hopefully after your SPM, your IGCSE and so on. Please join our foundation in science or foundation in business program. Thank you so much guys, and enjoy your weekend. Bye everyone.